Welcome to topic 2 of computer programming. And this topic has two subtopics, and those subtopics are stages in programming and syntax and semantics. So first of all, stages in programming. So programming, much like cybersecurity or like any good thing really, isn't a one-time event. Okay, you don't just write the program and then that's you done for life. Okay, so programming, in the same vein as cybersecurity, is actually a process as opposed to a product. So, what are the stages in programming? I hear cries from the distance, someone at the back shouting. Okay, so the stages in programming are not set in stone. There is no IEEE standard of stages or anything, but here I've attempted to kind of divide the programming process into 5 stages. So developing a program involves steps similar to any problem-solving task, and there are 5 main stages in the programming process. So the first stage that we have is defining the problem. So it's very, very difficult to solve a problem if you don't know what that problem is. And in that case, we need to firstly define the problem before we can get in and try and solve it. Once we know what the problem is, we can move to stage 2, which is planning the solution. And then coding the program is actually the middle stage. So we don't just sit down and start writing the program straight away, not until we know what the problem is, until we can plan out the solution. So coding the program will take place after we've planned out what we're going to do. Then we have 2 other stages: testing the program we've written. It's all very well writing a big giant program, but never testing it, and then it doesn't work in the end, and then running away. And the last stage is documentation, documenting the program. So internal documentation, writing comments, and maybe some external documentation as well, maybe a user guide, so that if you were to leave the company or organization that you were working for, you wouldn't just leave behind a giant program with no documentation. That would make it very difficult for someone to take over and make some changes or updates to your program. So let's have a look at each of these stages in a bit more detail. Right, defining the problem. So first of all, programmers are often contacted because their services are needed. They meet with users from the client organization to find out what the problem is. Sometimes they might meet with a systems analyst who will outline a project or issue that a program is required to solve. Then, once we define the problem, this actually consists of identifying what it is you know, so what's going to be input, and what it is you want to obtain, so what's going to be output. And eventually, you'll produce a written agreement that, among other things, specifies this input, processing, and output. And that written agreement is often called a requirement specification. Stage 2, planning the solution with flowcharts. So, one way to plan out a solution or program is to create a thing called a flowchart. Now, flowcharts are simple diagrams that consist of arrows representing the direction that the program takes, with some shapes that represent actions. And we have a couple of standards. There's the ANSI American standard, and there's also the British standard 4051, created in 1973, and this specifies some symbols for using in flowcharts. And we have down here, we have a terminator for starting or ending. That's a sort of oval shape. A process step is in a rectangle, and a decision is in a diamond shape. So let's have a look at these shapes when we put them together. Right, here we have a flowchart, that starts off with a start terminator here, then flows to some process step in a rectangle, and then flows to some decision. So this one is a flowchart that's all about looking for something that's lost. So when I was younger, if you lost something, my granny used to say you should pray to St. Anthony. But obviously that's not included in this flowchart here. This is a more atheistic approach to looking for something that you've lost. So you start off, you've lost something, okay? So the first thing you're going to do, the first process, is you're going to look for the item. Did you find it? This is where you make a decision. If the answer is no, you're going to ask, well, do you really need that item? If it's your car key, probably. So you're going to go back to yes, and then you're going to look for it again. And there we can just travel around through this sequence until eventually we do find it, and then we can stop looking, okay? Or we could eventually leave out and think, well, you know what? I don't want to take the car anyway because I want to get a bit of fitness and I'll just walk and I can't be bothered looking for the car key anymore. So no, I don't need it, and stop looking. There we go, and we're out. So here's a second one. A lamp doesn't work. So we have a lamp and the lamp doesn't work. I'm sure many of us have encountered this conundrum out there. So the first step is the lamp plugged in? Let's make this decision. No. Then plug the lamp in. Okay. Is the bulb burnt out? Yes. Replace bulb. No. The lamp must be broken somehow. I guess another stage we could add would be to change the fuse in the lamp. Now, bulbs don't tend to burn out so much anymore. In the 90s, they used to. But since we've started using energy-saving light bulbs and LED light bulbs and things, I suppose this is more of a kind of once in 10-year event. I don't think I've ever had an energy-saving light bulb fail. They last so long, especially an LED one. So it'll be interesting to see what happens with those. Right, the final one. This is quite a philosophical approach to shopping. So imagine we were in a situation where all the shops were open and we could go to visit a retailer. We walk in and we pick up an item and we think, does this item spark joy for me? No. Throw it away aggressively. Yes. Keep the item, put it into your shopping basket and take it on. So there's some examples of some flowcharts there. Now, another way of documenting a program is to use a thing called pseudocode. Pseudocode actually has a silent P and a silent E at the beginning, making it quite a challenge to say the thing, never mind write it. So pseudocode is an English-like non-standard language that helps you state your solution with more precision than you can in plain English, but with less precision than is required writing a formal programming language. So pseudocode permits you to focus on program logic without having to be concerned about precise syntax. And obviously the computer can't execute pseudocode, but it's a good way of starting to lay out a program. So here's some examples of some pseudocode. So if student grade is greater than or equal to 70, print passed, else print not passed. Okay, so this wouldn't work if we tried to run it with an interpreter, but we could take this and change the syntax of it and convert it into a running program. Okay, here's another one. Start program, enter two numbers, A and B, add the numbers together, print the sum out, and end the program. So there's a couple of examples of pseudocode to help planning the solution. Now, stage 3 of the programming process is coding the program. So coding is just expressing your solution in a programming language. So up until this point, we can be fairly, we can change the language that we're going to use. Okay. At this point though, we have to pick a programming language. And in this course, we're going to use Python. but you could use Java, JavaScript, C#. It would be up to you. If you had the planning documents, the pseudocode, the flowcharts, you could go away and then convert those into running code. Now, to get this to work, you'll have to follow exactly the rules of the syntax of the language that you're using. Okay, step 4, testing the program. Some experts insist that well-designed programs can be written correctly the first time. I would debate that. I would say that when you're writing a program, you'll very often make small mistakes and you'll go back and change them. No one just writes a program that runs first time perfectly, or if they do, that's a very, very rare occurrence. So this can be a little bit discouraging at first, but honestly, you get used to running something and rerunning it. And what I always say is, you make a change, you run it. You make a change, you run it. So eventually, after coding the program, you'll have to try and run the program, do some proofreading, and debug any errors that come up as you go. And normally, the programming language interpreter will pick up things like maybe missing characters here or there and help you to fix them to get the program to run. Okay, so the last stage is documentation. So this is an ongoing necessary process that allows a detailed description and facts about the program to be documented somewhere. So inside the program, we can have comments. Those are called internal documentation. And it would be helpful if we had some sort of user guide, as well as some flowcharts and a list of changes made, who made the changes, when they made the changes. That's called change management. So turnover in the IT industry is quite high. So written documentation is quite important because it's likely that someone will come along after you and have to make changes to your program if your program's being used somewhere. So comments can be added in Python quite easily just by putting this symbol at the start, this hashtag symbol or the pound sign. I think this is actually called an octothorpe is the name for it. So if we put this pound sign at the beginning of the line, this tells the interpreter just to ignore it. And this is for a human readable comment. And hopefully we write these comments are useful. So it's important to think that documentation is the most important part of the whole process, because without the documentation, the program is a black box. It performs a function and we don't know how it does it. Okay, so cast your mind all the way back to the beginning when I said that the first stage is defining the problem. So when we define the problem, we will create a written agreement. And that written agreement is called a requirement specification or a software requirement specification. Now, this lays out the functional and non-functional requirements of the program. So if I said to you, I want you to build me a web service that performs mathematical calculations, it works out tax on income or something similar to that. And I also said to you that I want all the buttons to be yellow. Okay? Now, if I was to put in a number to calculate some tax and I was given the wrong answer, then that would be a functional requirement. That's a functional requirement. It has to be able to calculate the right answer. However, you could say that I want all the buttons to be yellow would be a non-functional requirement. Because if the buttons were orange or green, then the program would still work. So it doesn't affect the direct function of the program. But at the same time, we do want it. It is down there as a non-functional requirement. So another reason that we create a requirement specification is because of a concept called the scope. And there's a thing called scope creep. And what scope creep is once you start a project, it's possible that the parameters or the requirements of that project will change. And if that's the case, that can cause you more work. So you want to have a written agreement of what actually is required so that you can deliver exactly that and not something else that they've come up with later on. Okay, so it also helps ensure that these requirements are filled on behalf of the customer as well, not just for yourself. So here's a really basic outline of what we can have in a requirement specification. 3 main sections, each of which could be divided up into some subsections. So the first section, the introduction, will state what the purpose of the software is, the intended audience, the scope, very important, and the definitions and acronyms. So let's say it was in a particular industry, there might be some acronyms or abbreviations that they use all the time. It might be worthwhile getting them up at the front to save you typing out these whole statements over and over again. Part 2, the overall description, the user needs. So what do they actually need? They need a program that, then you fill that bit in. What do they need? So it's often very difficult initially to pin down what it is that someone wants. I built a web service for a customer once, and in the beginning they were talking about it as if it was an idea. And I was like, okay, I understand your idea, but what is it that you want? And it turned out that what they wanted was a website. And I was like, okay, so we know you want a website. Now, what do you want in the website? And they were like, I want people to be able to share ideas. And I was like, okay, how do you want people to be able to share ideas? And what they actually wanted was they wanted people to be able to post videos to a website about certain topics. And I was like, right, so you want a website capable of hosting videos that users can upload. That makes more sense. At the beginning, you said you wanted an idea. You know, you wanted you were calling it a project or an idea. Then I managed to drill them down to what it was exactly they want. So this is where we find out what the user needs. The user needs, it's, you know, the people who are going to use the software to be able to upload videos. So that would be a functional requirement. Okay. Whether the videos look good initially, that would maybe be more of a non-functional requirement. We need to be able to get the videos up onto the website first. Okay, so then part 3 would be about system features and requirements. What are the functional requirements? What are the non-functional requirements? Then we have things like system features, external interface requirements. You know, do we need particular types of software, or does the software have to interact with an existing system of some sort? So there's a really basic overview of a requirement specification outline. Now, once you'd produce this document, it would be signed off by you and by your client, and then you'd agreed that. Then you could go away and start creating the software once you both agreed what it was you were going to do and what the scope of that was, and also what you were not going to do. So that is the end of the first topic. The second topic is about syntax and semantics. So syntax is which groups of characters and symbols are well formed. Okay, so here we have, if I was to send you a message that said this, that would be a syntax error, because you would think, what does this message mean? All I asked was, what time are we having dinner? And you sent me back this. So all languages have a syntax. And if we think about the sentence, car our walk, if I said to you, car our walk, that's a syntactically valid sentence. You know what car means, you know what hour means, and you know what walk means. But it doesn't make sense, okay? If I said to you, no compro manzanas, right? That's a syntactically valid sentence, but in Spanish. So that's not any use in English, is it? So you have to actually follow the syntax of the language that you're using as well. So we can have sentences that are syntactically valid, car our walk, or no compro manzanas. Okay, but these aren't violating any particular syntax errors like this one is, the H1287. So what we think of as they're violating, these are semantic errors. Okay, so I did this graphic here. So we've got this gentleman here with a tie on, probably at the end of a dinner party or such, and he says to this lady here, "Call me a taxi, please." And she says back, "So do you want me to call you a taxi? Like, do you want me to refer to you as Mr. Taxi? Or do you want me to contact a taxi company and order a taxi for you?" Okay, so the problem that we have is in English, a sentence like "you is cold" is syntactically valid. It doesn't violate the syntax of English, but it's still not valid because "you" is plural. It should be "you are cold." So this sentence actually breaks the static semantics of English. So static semantics are where we have a sentence that's syntactically valid, but it still doesn't make sense. Okay. Another type of semantics are the full or the formal semantics, and those are the meanings associated with things. So let's say we have another situation where you say a sentence, and that sentence is syntactically valid, and it doesn't violate the semantics, the static semantics of English. So firstly, it makes sense. Secondly, it's syntactically valid, okay? Just like this gentleman here saying, "Call me a taxi." Okay, there's nothing wrong with that sentence. But because it's an ambiguous sentence, it can have multiple meanings. This violates the full or formal semantics of the language. Okay, you have to clarify what you mean. So English can be an ambiguous language, and some sentences can have two meanings. This is where the full or the formal semantics comes in. So luckily for us, in programming languages, each sentence or each command only has exactly one meaning. Okay, so that's good news, but the bad news about that is that meaning might not be the meaning that you want it to be. So which errors are worse? Syntax errors are really common, and the computer can find them easily. Like if you misspell a word, the computer will say, syntax error, and those are quite easy to fix. Okay. Static semantic errors are usually caught when the program is run. So let's say you've got an output, but it's not quite the output you want. Okay, that's a static semantic error. So those are usually caught when the program is run, and they can make the program behave unpredictably. The worst possible situation would be that the program gives out an answer and we're happy with the answer, but the answer is actually wrong. Okay, so that's the worst situation we can have. Errors in Python, because Python's an interpreted language, it picks up errors as it runs. So if you have a syntax error on line 10, you start the program will stop running at line 10 and it'll say syntax error. Now, when we run a Python program, it runs in a shell, and it's called a shell because it hides what's happening underneath. And usually if we find syntax errors, those are easily picked up by the programming language. So I'll just grab a Python shell here. Let's just open up our idle. Okay. And if I was to type in here, print, okay, hello, and run that, it should print back hello. There we go. Now, if I take this and try and run it again. Okay. But I take out this bracket here, this double quotes. Let's run that. Now look, syntax error. Okay, so it's telling me that there's an error, and it's even highlighted that bit in green because it likes that bit, and it's trying to show you where the error is. So let's see, let's pop this in here, go back to here, and if we put the double quotes back in, you'll see that this goes green. And this kind of color highlighting is just trying to help us. So let's run that. And there, now it's working. Now it's happy. It doesn't have a syntax error. So that concludes topic 2, stages in programming and syntax errors. So we'll stop this now and see if anyone has any questions. On the Moodle page, we should have the presentation for stages in programming, and I've also added some learner's notes about flowcharts. Okay, and these learner's notes go into a little bit more detail on how we can put together flowcharts and some pseudocode. Now, Lab 2 involves actually putting that into practice. So let me show you Lab 2 just now. And in Lab 2, what we're going to do is we're going to return to looking at algorithms, and we're going to write out an algorithm to determine if a number is an even number. First of all, using pseudocode. Then we're going to draw this as a flowchart. Now, a bit annoyed about that there. Let's just change that. So there are various software programs out there that will allow us to create flowcharts. Okay. However, I've got a good website we can use called apps.diagrams.net, and it means that we don't need to install any software. So if you want to go and use a flowchart making program, that's fine. However, app.diagrams.net, if we click create new diagram, and then we click flowchart, and then we give it a name, let's just call it flowchart 1, if we can. And then we click create. Right, here we have a flowchart maker. So this is our favorite one from earlier about lamp not working. So let me just delete this, and I will show you the stages in creating a simple flowchart using this software, so that if you want to go and put this into practice yourself, you can do. So I'm trying to now, let's just get me the view, and let's zoom the view in a little bit. Let's stick it to 150. Okay, so let's say we're going to make a simple flowchart about going to the shops and buying lunch. Okay, so let's grab one of these oval shapes, and we can use this as a start terminator. Okay, let me just make this a little bit smaller here, and let's just go start. Okay, we probably don't need it to be that big either. Now what I'm going to do is right click, and I'm going to do duplicate. I'm going to pop this over here, and I'm going to change that to end. We could write finish here as well. We're not going to write it in finish. That would be more difficult to read. So let's put end there. Right. So let's say we're going to go to the shops to buy some lunch. Oh dear, there's an arrow coming out there. Right. Let's go to the first process. Okay. So the first process is, okay, right, go into the shop to buy lunch. Okay. Americans would call this a store. All right. However, I would kind of disagree with that. I would think a store is where you store things. Okay. Like kind of like a warehouse or something. And a shop is where you go to shop. But let's not get into that today. Okay. So we're going to go to the shop to buy lunch. Now, the first thing we're going to do is we're going to make a decision here. Okay, and we use a diamond to make a decision. So when we drag the shape about, these blue lines that pop up allow us to align things evenly. Okay, and in here we're going to say, do you know what you want? Let's put an N in there. Do you know what you want? Let's make that. We'll get there. Okay. Do you know what you want? Right. If the answer is yes, okay, so let's put a process over here. And let's put a process. Okay, so let's go and we'll duplicate this. And let's put a process down here. And let me just adjust the screen slightly. So let's go there. So do you know what you want? Yes. Make purchase, leave shop. Okay. And then we can put end down here. Okay. And then over here, we can put have a think about it. Okay. Have a think about it. Let's put that with a capital H there. Have a think about it. Now, the next thing we're going to do is add some flow to this. So let's just grab a wee arrow. And if you just click on a area and just drag, a wee arrow will just appear. Okay. So we can just add in these little arrows here. Okay. And let's put an arrow over there. Oh, I don't like how it did that. Let's just maybe just line the, there we go, line that up straight there. Let's just pop this over here. And then let's just do up and along. Okay, and it's going to be, there we go. I figured that out. So let's put here, no, and let's put in here, come on, yes. Maybe we'll do it with a capital Y. Yes. And then if we want to make this look a bit nicer, okay, let's come up with a nice color scheme. So let's make the start a sort of yellow color, and let's make the end a sort of yellow color. Let's make the decision a red color. Let's make the processes a nice sort of pale green color. There we go. So now that we've created this relatively simplistic flowchart, okay, let's just make, okay, what we're going to do now is we're going to export it. Now, if we go up to File and click Export As, we can download this as a PNG file, a JPEG, scalable vector graphic, PDF, VSDX file, HTML, XML, URL, or advanced. So let's just go, let's just keep it simple. Let's go for a PNG. Okay, stick it on transparent. And let's just export. Now, it will allow us to send it to Google Drive, OneDrive, Dropbox, but just choose device. And then it will download. And if we click here, okay, we now have a flowchart downloaded. There we go. Okay, and we can add that to a document. Now, I know that was a very silly process, but hopefully that highlights how straightforward that is. And hopefully that should help everyone to be able to create pseudocode and flowcharts. Okay, so this actually comes to a head at the end when we're going to use some top-down design, which is explained in the learning notes, to create a flowchart to represent the steps in the card game of 21. So to do that, we're going to start with dealer deals cards, then player looks at their own hand. Okay, so let's start that off over here. Let's change up this flowchart a wee bit. So let's do dealer deals cards. Okay, now decision. Okay, dealer deals cards. Let's pop in player looks at hand here as well. Okay. Player looks at own hand. Maybe we'll need to make this slightly bigger to accommodate that. Let's just nudge that over there, nudge that down there. Okay, cool. Now, what's the decision that we're going to make here? The decision that we're going to make is how many, what is the value of the hand? Okay. Now, I'm not going to do the rest of it for you, but that's certainly how you would start it off. Okay. So what's the value of the hand? Now, if you're unsure what the game of 21 is, okay, there's a link here that you can click on and it will take you to explain the game of 21, okay? It was formerly known as 21, which just means 21 in French, okay? So there we go. So that's lab 2, topic 2. This is topic 3 of computer programming. And in this topic, we have 3 subtopics: structured programming, editing programs, and testing programs. So firstly, structured programming. Now, in Fortran, which was a very old language invented in 1954, and in low-level machine languages, there is a statement called the go-to statement. Now, Dijkstra recognized that there was an issue with the go-to statement and wrote a paper called Go-To Considered Harmful in 1966. It was determined shortly after that that the go-to statement is not needed at all for programming. And this was the birth of a discipline called structured programming. So if we have a look at a structured approach, we've got an if statement and a loop. And if we have a look at the unstructured approach, we have an if statement, then we go to someplace, then something happens, we can go to 1, okay? So structured programming is what we're aware of. The unstructured approach is using the go-to statement. And a little graphic here of Bart Simpson writing, the go-to statement is considered harmful. Editing programs. The good thing about Python is it comes with a simple editor called idle. Now, Python being named after Monty Python's Flying Circus, idle is named after Eric Idle, the actor. You can look him up if you're unsure who Eric Idle is. Now, idle is a free download and it's Python's integrated development environment, Python's IDE. And it has 2 main windows, the shell window and the editor window. And it's a very, very simple editor to use. So when you go to the Python website, python.org, you download the latest version, it'll already come with idle. Now, here's my idle shell here. And I have gone into the configure options and I've changed the highlights from the classic view, which looks like this, to the idle dark view. I just find it easier to use light text on a dark background, but that is your preference. There's classic, dark, and new. And then you can go to the fonts and you can set it to a font that you want. I'm using a font called Source Code Pro. And the size, I've deliberately put it up to 20 so that, you know, when I share my screen, it's easy for people to see what it is I'm doing. So now that we have the shell open, okay, we can do 2 plus 2 and Python will return 4. If we want to write a program that's longer than, say, 1 line, we just do File, New File, and this opens up a new idle window and we can write our program, write program here with an R. And then to save it, we can either go File, Save, or we can just do Run module, or even easier, we just press the F5 key on our keyboard. F5, then it will say the source must be saved. We just press Return. We give the program a name, and then it will run over here in the shell. Now this would give an error because this is just an English, just a nonsense statement. So that's the simple idle editor there. Let's just close that down and let's minimize this. Right. Here is the Python program here, and here is the idle editor here. Now this is actually Python 3.6. I think we're up to Python 3.9 or something like that. So let's go a little bit further forward, okay? So we have a simple editor in idle. Now, there are other editors that you can use, and here's a couple that I would recommend having a look at, okay? This one here is called Thonny, all right, Thonny, and this one here is called Genie, okay? Now, Thonny over here and Genie, they're both very small, okay? There are other editors out there. There's Visual Studio Code, if you like Microsoft. There's also one called PyCharm. There's Anaconda. Probably all I can think of at the moment. I'm sure there's many editors. So the one I like to use is Genie, and I'll show you my Genie here. So this is Genie. So we can print, right, hello world over here. Okay, this is the editor window in Genie, and then if we do file save as, and we just save that as hello.py, okay, this saves over here, and it's got a nice kind of color theme. Now if I run this with F5, it runs over here at the side in the terminal, and I've got a nice pink and black theme for my terminal as well. So that's the Genie editor that I like to use if I'm writing a Python program. So we've got print hello world, and it comes up with nice nice color highlighting. But what to do is this is a very lightweight program. This is only maybe less than 30 megabytes. So certainly have an experiment and find out which editor works best for you. Okay, so that's editing programs. Now testing programs. So testing programs, right. The basic idea behind testing is that you're not looking to find bugs or to make software better, but you're looking to reduce risk by finding and eliminating problems which would impact the customer using the software. Okay, so a software bug is maybe something that we would troubleshoot when we were checking the program. Okay, but the debugging process can take place when we're running, but testing takes place after the program is up and running. So after we've got rid of all kind of bugs and obvious syntax errors and it's running, we can then do some testing. And, you know, part of the testing, how we could start that off would be by creating a test plan. Okay, so the test plan will say, how will things be tested? Now, a test plan could be in a Word document or in a spreadsheet, and it's just a list of all the different tests that you're going to do. So, for example, if you had a program that was a simple calculator, you might want to test you might want to test, does it add properly? Does it add two numbers together? Does it divide? Does it multiply? Does it subtract? Can it do percent? So you would write out all these different test cases, and then you would put what the expected output was, and you would put what the actual output was, and you would see if you can find a problem with the program. Now, I knew a guy who loved writing test plans, and he once wrote a test plan that was 250 A4 pages long. Absolutely loved writing test plans. Just, it was his favorite thing to do. Very strange man. So, different types of testing we can have. Black box testing. Black box testing is testing the software itself as if it was a black box. Okay, so we can't see into the code. We just send input and we wait and see what output comes. Okay, now the end user unwittingly will be doing black box testing because they won't know how the program's working inside. They'll only put some information into the program, and then if something comes out wrong, they can maybe tell you about it, but they won't be able to tell you why or how. So that's black box testing. Then we have white box testing. White box testing is sometimes called glass box testing. okay? And this is when we have some idea of the software inside, okay? So if you looked at code that did complex calculations for accounting software and you saw that there was a section that worked out tax, for example, you might be able to write test cases to target that particular part of the software because you know how the software works inside. So you'll be able to create tests for particular scenarios based on the fact that you know what's in the code. So there's some other types of testing. Acceptance testing. You have some tests which test the actual requirements or expectations of a customer. This is sometimes called user acceptance testing. So does the user accept that this works in the way that it should? Okay, and this would evaluate systems compliance with business requirements. Another one, very common, automated testing, where you run the code through an automated verifier or tester just to check that everything's working. Regression testing is when we add a new feature to software. It might be that later on we want to check that old features still exist. So let's say a client is really wanting a new addition to the software and you make that addition, but it breaks 5 old things. Regression testing would catch this, okay? Most automated tests are regression tests, and they can go back and just check that the program's still functional for its other purposes, not just, you know, the new feature that you've added. It's all very well adding a new feature, but if it breaks all the old features, then it kind of makes the program invalid. Functional testing is testing things like performance, usability, resilience, security, scalability. Functional testing is a kind of testing where you're concerned with the system doing what it's supposed to do from a functional perspective. Okay, so if you put in some input and push a button, what output will you get? Okay, so you're not bothered what happens, you're just bothered about the function of the program, the input and the output. So some other forms of testing would be load testing, recovery testing, security testing, stress testing, usability testing, accessibility testing, exploratory testing are some examples. There are many different kinds. That's just a highlight of some of the basic ones. Okay, the last bit today is about PEPE8. So PEPE8 is Python's style guide. Now, PEPE8 has a syntax checker. Okay, so let's just jump onto our syntax checker here. And let me just come up with a quick Python program. Okay, so we've got print hello world twice. Okay, what I'm going to do is I'm going to have a variable called x, and I'm going to set that to be equal to 5. And I'm going to print x. Okay, and I'm going to maybe leave another bracket there. And let's do hello here. Now, I've done this with deliberately a few problems in it. I mean, even if I run that, it's giving me a syntax error and it's telling me that it's the extra bracket. But let's just take this and put it into the PEPE8 syntax checker. And let's check. Okay, we have 4 problems with this. So let's take these out one at a time. Line 5, a block comment should start with a hashtag and a space. So let's put a space in there. Check again. Okay, now we have 4. Missing white space around operator on line 6. So what it means is it likes you to have a space around the operator. Okay, let's run this again. No new line at the end of the file. That's an easy one to fix. Let's just put a new line there. Maybe that's 2 new lines. Let's just go for 1. Let's check again. Finally, end of file in multi-line statement. I'm guessing that's maybe that. There we go. So this is now PEP8 requirement happy. Okay, this is now PEP8 compliant, this code. Okay, so that's the PEPE style guide. Now, Python will still run without following PEPE. PEPE is just designed to make large code bases more uniform and easier to read. Okay, and I've added a link to a guide to it there. So that is the end of topic 3. And I'm just going to jump over to the middle page and show what's in the lab 3. So here's topic 3 here. There's some learner's notes, and the learner's notes are about iteration and recursion. Okay, so they just go over a couple of simple functions, simple methods, and then we have a look at lab 3, algorithms and getting started with Python. So let me just open this up just now. Okay, so lab 3, algorithms and getting started with Python. So if you haven't already, now it's time to install Python on your computer, and you can do that by going to python.org, downloads, clicking on your operating system. So let's say you're using Windows, you click Windows, and then you just want to download the latest release of Python 3. Okay, we don't want Python 2, we want Python 3. So we click here, downloads all releases, download Python 3. There, click that big yellow button, download it, it'll install, and then you just want to click start and type idle, and idle will open up. Okay, so once you've done that, create a simple hello world program. Then you create some other tasks. Then you try and generate some syntax errors. Then you create a little bit more of some print statements. And then we're going to take some user input. Okay, get a user to enter a number. And then we're going to modify this program to say hello to the user. So actually, I'm just going to change that to, that should be lab 3. That's all looking good. Let's just change that as well. I don't know why whoever wrote this didn't spell that with double M. Okay, so that's lab 3. The last task in lab 3 is about downloading this file called fixingprints.py. So I'll have a look at that just now. Fixingprints.py is a Python file that's full of mistakes. So if we copy this file into our, in fact, I'll copy it into idle, okay? Copy it into an idle window. Let's just minimize this. Paste. If we press F5 to run this, okay, let's just call it fixing prints. It's going to say invalid syntax. Okay, why is the syntax invalid? We need to fix that. Okay, there are lots of problems in this file. Okay, you can probably see by stuff not being highlighted. All I want you to do is go through this file and fix the syntax so that it runs properly. And that is part 3.11. So in summary, what we need to do this week is, under tasks for this week, read the learner's notes for topic 2 and topic 3, then complete and upload labs 2 and 3, including this little fixing prints task that I showed you.